So in this class we will study about the composition of functions and invertible functions. So now what is meant by composition of functions? So composition means combining the two functions. So for example, here is clearly it's given in the textbook. A is the one of the set, has only the one element, it is what x. Then B is the next one. In that element is what? F of x. So here it is our relation is that A to B, that is F. F is a function, is related with A to B. Okay, so it means if A is x and that function F of x is what? Here it is what? B. Okay, so now next, so one more you have to take it as C. Next, here is a function is G. So B to C is a function, it is what? G. Here F is a function from A to B and G is a function from B to C. A is x, this F of x is B. Okay, and then next we have to find this what? G of x. G of x is what? G of F of x equals to what? C. So that composition of the function is G of F. G of F. So from here to here it is what? G of F. So the meaning is what? Functions A to B and function, the function is x and G of F of x, A to C is there. So first from the function F from A to B and second from the function G from B to C. Okay, so totally it is what? A to C means G of F. This is our composition of functions. So for example, the definition what we can say here, let F from A to B and G from B to C be the two functions. Yes, this is the one function and this is the one function. These are the two functions. Then the composition of F and G is denoted by G of F. F and G is denoted by what? G of F. G and F is denoted by what? F of G. Okay, is defined as the function G of F from A to C is given by G of F of x is equals to G of F of x for all x belongs to A. This is our definition of the composition function. Okay, so for example, here only it is a given, let F is 2, 3, 4, 5, it tends to 3, 4, 5, 9 and G from 3, 4, 5, 9 to 7, 11 and 15. B functions is defined as f of 2 equals to 3, f of 3 equals to 4 and f of 4 equals to 5 is equals to what? 5 and G of 3 and G of 4 are equals to what? 7 and G of 5 equals to G of 9 equals to what? 11. Find G of F. So now we have to find for this G of F. So how can you find this? It means the function is already given f of 2 equals to 3 and f of 3 equals to 4 and f of 4 equals to 5. F of 4 and f of 5 both are what? 5 is given. It means this value is satisfying with this term. It means x is the term and f of x is the B set. So here A to B, this is all the elements of A here and this is what? F of x. Clear? This is what? B. Okay, so now f of 2 equals to 3, f of 3 equals to 4, f of 4 and f of 5 equals to what? 5 is given. Okay, so now we have to find G of F of G of F. G of F means G of F. Okay, so I will write now. Here it is what? G of F we have to find. So G of F we have to find F function F from which to which? 2, 3, 4, 5 to 3, 4, 5, 9. Okay, so this is what F now. 2, 3, 4, 5. Now first we have to take it to us F. G of F we have to take it. Now G of F is F of 2 we have to take. F of 2 means G of F of 2. G of F of 2. So now G of F of 2 how much is given? F of 2 is what? 3 is given. No, 3. F of 3 is 3. Now what about the G of 3? So now it becomes what? Here it is G of 3 is over. We will got G of 3 we got. So what about the value of G of 3? G of 3 is what? 7 is given. No? So now G of 3 equals to what? 7. Okay. So now similarly we have to find the G of F of 2 over next it is what? 3. Okay, now G of F of 3 G of f of 3. Now g of f of 3 is how much? F of 3 is 4. F of 3 is what is given? F of 3 is 4 is given, 4. So now this is what 4. What about g of 4? So g of 4 is also given what? It is 7. This is what the 7. Now next, what about g of f of 4? G of f of 4 is nothing but what? F of 4. F of 4. So g of f of 4 is 5. F of 4 is 5. Next, g of 5 is, understood now everyone? It is what? 11. Okay. So now what about the g of f of 5? G of f of 5. So g of f of 5 now. G of f of 5. F of 5 is 5. It means g of 5. So g of 5 is 11. G of 5 is 11. So now what about this g of f? G of f is can be written as 2, 7. Next 3, 7. And this is what 4. 4, 11. And 5, 11. Okay. So this is the word function. Composition of functions. So we have to find like this. So I hope that this is what clear. Now we can simplify some more problems. Then afterwards I will say what is that invertible function. Okay. So now I'll move to exercise number 1.3. Directly I go to that exercise number 1.3. In that exercise number 1.3, the first one is let f from 1, 3, 4 to 1 to 5 and g is another one function. It is 1 to 5 to 1, 3 be given by f is 1, 2 and f 3, 5, 4, 1 and g equals what? 1, 3, 2, 3 and 5, 1. Okay. So write down g of f. So write down g of f means the previous example here I considered one example that is a same as this one now. But here it is what? F is given. F is given means 1, 2 and then 3, 5, 4, 1. Okay. Next g is also given. G is 1, 3, 2, 3 and 5, 1. Okay. So now we have to find g of f. So here it is 1, 3, 3, 5, 4, 1 means x is 1, f of x is 2. If x is 3, f of 3 is 5. X is 4, f of 4 is 1. Okay, that is the meaning. Then here g of x is 1, g of 1 is 3. Here x is 2, g of 2 is 3. X is 5, g of 5 is 1. Okay, so this is the thing. Now we have to find f from, right? F from 1, 3 and 4. So now we have to find the g of f now. So now g of f of 1 we have to find first. G of f of 1 we have to find first. So g of f of 1. What is that g of f of 1? F of 1 is 2. Okay. So now g of 2. What about the value of g of 2? G of 2 is 3. So here it is for 2, 3. Clear? So now you can say clearly next one is g of 3. So now g of f of 3. G of f of 3. So now g of f of 3. F of 3 is how much? F of 3 is here. 3 is here and f of 3 is the range. It is what? 5. Okay. Now g of 5. What about the value of g of 5? G of 5 is and 1. Clear? I hope that all of you clear have understood. Now what I have to take it? It is what? 4 I have to take. Next it is what? G of f of 4 equals to g of f of 4 is f of 4 you have to check it here. This is the function f 4, x is 4 and what is f of 4? F of 4 is 1. Okay. Now g of 1 is a function is here. G of 1 is here. 1 that g of 1 is 3. So this is our 3. Now what about the last final answer? Therefore g of f is equals to what we can write. This is what? 1 and 3. 1, 3. Next this is 3 and this is 1. So 3, 1. Next 4, 3. 4, 3. This is our g of f. So I have that here clear here, right? Okay. Now next second one I will explain later. Second one I will explain later. Now third one I am going to explain. So now third one. Third one is we have to find g of f and f of g. If the condition is, the first one is f of x equals to modulus of x and g of x equals to modulus of 5x minus 2. The second one is f of x equals to 8x cube and g of x equals to x to the power of minus x to the power of 1 by 3. Okay, so now first one I am taking now here. First one, f of x equals to, how can I write f of x? F of x equals to modulus of x. Okay, and g of x equals to 5x minus 2. 5x minus 2. Now I have to find g of f. Now I have to find what? G of f. How can you write this g of f? So g of f is nothing but g of f of x. G of f of x. So here g of f of x is g of modulus of x. Correct? F of x is modulus of x. So g of f of x is modulus of x. Now g of x is given as modulus of 5x minus 2. But x is modulus of x. So modulus of 5 of modulus of x minus 2, modulus is closed. Okay, this is what? F of g of f. And now for this f of g, how can you find f of g? F of g is f of g of x. F is outside now. G of x is, this is what g of x, modulus of 5x minus 2. Modulus of 5x minus 2. Modulus of 5x minus 2, 5x minus 2 is g of x. So g of x place you have to write like this. Now this is what full is x. So this is what f of x is x, modulus of x. So the answer is modulus of 5x minus 2, modulus is closed and outside modulus is also closed. Modulus of modulus means it is modulus of 5x minus 2. This is what? F of g. This is g of f and this is what? F of g. Okay. So now I am going to explain a second one. F of x equals to 8x cube. F of x equals to 8x cube and g of x equals to x to the power of 1 by 3. Right. So now g of f is nothing but g of f of x. G of f of x. G of f of x is what? Here it is what? 8x cube. 8x cube is what? G of x. Now this is full is nothing but what? X. So x to the power of 1 by 3 is g of x. So this can be written at 8x cube to the power of 1 by 3. Okay. So x is what? 8x cube. So 8x cube to the power of 1 by 3. Now we can simplify this. 8 can be written as 2 to the power of 3 into x to the power of 3 to the power of 1 by 3. So now this can be written as 2 into x. So it is what? 2x. So g of f equals to what? 2x. Now f of g we can simplify it now. F of g of x. F of g of x. So here f of g of x is what? X to the power of 1 by 3. G of x is x to the power of 1 by 3. Now g of x is x to the power of 1 by 3. Now f of x is 8x cube. X place we have to substitute it here. 8 into x to the power of 1 by 3 to the power of 3. Okay, x is how much? X to the power of 1 by 3. To the power of 3 is there outside. So now this is what? 8 and this get cancelled. It is what? 8x. So g of f equals to 2x and f of g equals to 8x. So this problem is asked in 2019 July. June question paper. Okay, 2019. So that's why this problem is one of the important problem. You can consider it. Next, in your textbook, one example is there. So here you can see that example. Find g of f and f of g if f from R to R and g from R to R is given by f of x equals to cos x and g of x equals to 3x square. So show that g of f is not equals to f of g. Okay, so we will simplify this problem now. how we are getting that answer? F of x equals to h cos x and g of x equals to 3x square. So now first I have to find the g of f. So g of f of x is nothing but g of f of x is cos x. Cos x. Now this is what x is cos x. So g of x is 3x square. 3 into cos x whole square. 3 into cos x whole square. It is what? 3 cos square x you are getting. Okay, this is what? G of f. Now f of g. What you are getting? F of g. F of g can be written as f of g of x. It is f of g of x is 3x square. G of x is 3x square. Now f of g of x means f of x is cos x. So cos of 3x square. So cos of 3x square. Cos of 3x square is nothing but cos 3x square. Cos 3x square. So now g of f is 3 cos square x and f of g is cos 3x square. So it is not equal to same. Therefore g of f is not equal to f of g. Okay, so this is also one of the very important problem. It is asked in 2014, 2016 and 2018 also. 2018. Okay, so this is also one of the very good question. You can understand easily. So now I'll move to that exercise question. Fourth one. F of x equals to 4x plus 3 divided by 6x minus 4 and x is not equals to 3 by 2. X is not equals to 3 by 2. Show that f of x equals to x and what is the inverse of f. So what is the inverse of f? So how can we simplify this? So first I have to take it as f of x equals to 4x plus 3 divided by 6x minus 4. X is not equal to 2 by 3. Then I have to consider f of x. So I have to find f of x. So f of x is equals to f of x is this 4x plus 3 divided by 6x minus 4. So now this is what f of x. X place you have to put this one. Here it is 4 into 4x plus 3 divided by 6x minus 4. X is over, then plus 3 divided by 6 into 4x plus 3 divided by 6x minus 4 into minus 4. Okay, so this is the way we have to simplify. Now, so if I am taking that LCM, denominator 6x minus 4 and 6x minus 4 get cancelled. So it is remaining 4 into 4x plus 3 plus 3 into 6x minus 4 divided by 6 into 4x plus 3 minus 4 into 6x minus 4. So why it is the denominator is cancelled, understood? So I will simplify it here. So if I am taking the LCM is 6x minus 4 over 4 into 4x plus 3 plus 3 into this term, right? 6x minus 4 I have to write. In the same way the denominator also will get like this, divided by what? 6x minus 4 and 6 into 4x plus 3 minus 4 into 6x minus 4. So this and this get cancelled. So that's why here we are getting 4 of 4x plus 3 of 6x minus 4 and divided by 6 of 4x plus 3 and minus 4 of 6x minus 3. Then after simplifying this you will get 4 into 4x plus 3. 4 into 4x plus 3 is 16x plus 12. 4 3 is 12. 16x plus 12. Next here it is a plus 18x minus 4 3 is 12 divided by we'll get 6 4s are 24x plus 6 3s are 18, then minus 6 4s are 24x plus 16. Okay, so now we have to simplify it. Here plus 12 and minus 12 get cancelled. It is remaining. What is answer we are getting? Answer is 34x divided by then here 24 and 24 get cancelled. This is what 34. So now 34 and 34 get cancelled. So what is remaining? This equals to what? X. So now when you are getting this answer as f of x equals to x, so already we proved that we have to show that what is that f of x equals to x. So it means f of x equals to x. Now what about the inverse? This is what over. So what is the inverse of f? So inverse of f, they both are equal means therefore inverse of f is f only. Therefore inverse of f is f. So why? F of f equals to I. F of f equals to I. I is a what? Identity. It's a mapping of r minus 2 by 3. So r minus 2 by 3. It is 2 by 3 is a question. No? In that question, what is that? X is does not equals to 2 by 3. Therefore, this f of x equals to what? I. It is identity mapping. Therefore, f inverse of f is f only. So now I will explain for you. It is what? Invertible. So now you know that it's an inverse. So now before that I have to explain that invertible. So what is that invertible? So what is this invertible? So composition functions of function and invertible function is there. What is this function as an invertible function? So invertible function is a function f from x to y is defined by a invertible. So f from x to y, I'll write the definition. F from x to y is defined to be a invertible if there exists a function g from y to x. Okay, f is a function. I have to say that is what? Invertible, x tends to y, and g is a function, g is what? Y tends to x, such that very simple, g of f equals to ix. G of f equals to ix is here, and f of g equals to iy. This value it should get. G of x equals to x, all these elements, and f of g equals to iy. This one, it is satisfying. Then this function g is called as inverse of f. Okay, so now it is satisfying. Then only we can say that function f g is called as inverse of x and is denoted by f inverse of equals to what? G. So what are the g elements is there? No, there is what? Inverse. Or f is a invertible if and only if f is a bijective function. You know that it's a bijective. 1 1 and on 2. Okay, so then only we can say it is what? Bijective function. Okay, invertible function. So it means f is a invertible if and only if f is a bijective function. So I hope that the invertible function is understood. A function f from x to y if is defined as the invertible if there exists a function g from y to x such that g of f is ix and f of g is iy. I is the identity term, you know that. So the function g is called as inverse of f. So this is what? Inverse of this. Okay, so this is our invertible function. For this example, we'll see that example in the exercise only we can consider it. Question number 5. State with reason whether following function has have inverse. So state the reason whether the following function have inverse. In the first question you can see f from 1 2 3 4 f from 1 2 3 4 to 10 with the f is a function 1 10 2 10 3 10 and 4 10. Okay, so now you have to check whether it is a inverse or not. It means you have to check it is out onto and 1 1 1 1 and onto. So first I'll explain that fifth question. First one, f is 1 2 3 4, it tends to what? It is 10. The function is given, what is that? 1 to 10, 2 to 10, 3 10, 4 10. Okay, so 4 10. Now f of 1 equals to 10 and f of 2 equals to 10, f of 3 equals to 10, f of 4 equals to 10. Okay, so now these all are what? Now this implies f of 1 equals to 10, it is equal, and f of 2 equals to 10, f of 2 equals to 10, but 1 is not equals to 2. If it is satisfying, this f of 1 equals to and f of 2 are both are equal, but 1 and 2 are not equal. Therefore f is not 1 1 function. If f is not 1 1, hence f does not have an inverse. So if it is 1 1, there is no inverse. Okay, so if it is 1 1 and onto, it has inverse. Okay, now second one I will check. Second one is g from 5 5 6 7 8 to 1 2 3 4. Okay, so with the function it is given g equals to 5 4 5 4 6 3 is given, 7 4 is given, and 8 2 is given. So now we have to check whether it is a 1 1 or not. Okay, now g of 5 equals to 4. No, g of 5 equals to 4, and the g of 6 equals to 3, g of 7 equals to, once again it's what, 4, and the g of 8 equals to 2. Here g of 5 and g of 7, so both are what, 4. So but 5 is not equals to 7, but 5 is not equals to 7. Therefore g is, what is the conclusion we can say? G is not 1 1. G is not 1 1. If it is not a 1 1, so we can say G does not have inverse. So I hope that all of you clear now, right? So now last problem, third one, I will explain. H is one of the function 2 3 4 5 to 7 9 11 13. With the function it is what? 2 7 3 9 4 11 5 13. Okay, so now h of 2 equals to 7, h of 3 equals to 9, h of 4 equals to 11, h of 5 equals to 13. H of 5 equals to 13. So both the values are different. Okay, so h of 4 equals to 11, h of 5 equals to 13. So everything it is here. Both are different. Hence h is 1 1. H is 1 1. Okay, now so you have to check whether it is onto or not. It means range of h we have to check now. Range of h. So range of h equals to, what are the range of h? 7, 9, 11 and 13. So this is equals to codomain of h or not? Yes, codomain of h. Codomain of h means it implies what? H is onto. Okay, so these all are the range. 7, 9, 11 and 13. These all the terms are there in the codomain of H. This is 7, 9, 11 and 13. Therefore, it is what onto function. Here it is satisfying both 1, 1 and onto. This was satisfying both 1, 1 and onto. Therefore, H is bijective. H is what? Bijective. Both 1, 1 and onto function. This is what? Bijective. Hence, H is invertible. Hence, H is invertible. Now, if H is invertible, therefore, what about the H inverse? So, inverse we have to find. Inverse we have to find means y comma x. Y comma x such that x comma y is belongs to H. It means H inverse equals to which one? Ulta pulta we have to write. So we are saying no. So 2 comma 7 is there means 7 comma 2. Next 3 comma 9 it becomes 9 comma 3. Next 4 comma 11 becomes 11 comma 3. And 5 comma 13 becomes 13 comma 5. So this is what? Inverse. Okay. So this is what? Invertible function. So now sixth one we will check. Show that the function f from -1 to 1 is tends to r. So yeah, sixth one. Show that the function f from -1 to 1 is tends to r. Okay, it's given by f of x equals to x divided by x plus 2 is 1, 1. Find the inverse of the function f from -1 to 1 tends to range of f. Is what? A range of f. How can you simplify this? We have to find inverse. Before that, we have to show that whether it is a function f from -1 to 1 is tends to r is given by f of x equals to x divided by 2. Okay, now I have to take it f of x equals to x divided by x plus 2. F divided by x plus 2 for all x belongs to -1 comma 1 and x is does not belongs to, it means does not equals to -2. If it is a -2, it becomes a non-defined term, no? Okay, now let x1 x2 is belongs to -1 and 1 such that f of x1 is equals to f of x2. F of x1 equals to f of x2. F of x1 means x1 divided by x1 plus 2 equals to x2 divided by x2 plus 2. Okay, this implies x1 x2 plus 2 x1 equals to x1 x2 plus 2 x2. This get cancelled, 2 get cancelled, x1 equals to x2. If x1 is x equals to x2 means it is a 1 1 or not? Yes, therefore f is 1 1. Therefore f is 1 1. Okay, now we can clearly say that f is 1 1. Then to find the range of f now. So to find the range of f, so if one f is function is 1 1 is over, we proved that is. Now we have to find the range of f. Let y equals to f of x. Okay, so let y equals to f of x. It means, this means x is equals to f inverse of y or not. This is what? Invertible, no? Y equals to f of x means x equals to f inverse of y. So here y equals to f of x means y equals to x divided by x plus 2. It means the cross multiply it, xy plus 2y equals to x. Now y I have to take it outside, x plus 2. Okay, so 2y is kept it here, then x minus xy, then 2y is write it here, x you have to take it outside, 1 minus y, then send 1 minus y to other side, you will get 2y divided by 1 minus y equals to x. Okay, so here y is does not equals to 1. Y is does not equals to 1. Why it is y is does not equals to 1? If you are taking y is 1, it is what 0. Okay, so now x equals to 2y divided by 1 minus y. Okay, now therefore what is the range of f? Therefore range of f equals to r minus only this 1. 1 is not including, then all the real numbers are range of f. So r, so range of f equals to r minus 1. Okay, so range of f equals to r minus 1, then hence the inverse. What about the inverse now? Hence f inverse is tends to what? R minus 1 is tends to minus 1 comma 1 is exists. Okay, this is our inverse. Now we have to find the inverse. To find the inverse, f inverse, let y equals to f of x. Now already said y equals to x divided by x plus 2, then xy plus 2y equals to x. Now x equals to what we got? X equals to y divided by 2y divided by 1 minus y we got, no? Now x equals to 2y divided by 1 minus y we got. Therefore f inverse of y equals to 2y divided by 1 minus y, or f inverse of x equals to 2x divided by 1 minus x. This is our inverse. So here only we got that x equals to 2y divided by 1 minus y. Already I said x equals to f inverse of y. What we are getting here x, this is what f inverse of y. So that f inverse of y equals to 2y divided by 1 minus y, or f dash of x equals to 2x divided by 1 minus x. This is the sixth problem solution. Now I am going to explain seventh problem. So seventh one is, consider f from R to R. F from R to R is given by f of x equals to 4x plus 3. F of x equals to 4x plus 3. How can you simplify this? Show that f is invertible. Find the inverse of f. So we have to show that it is f is invertible, and inverse of f also we have to find. So f of x equals to 4x plus 3. Okay, for all x is belongs to R. This is what condition. Now we have to show that it is a 1 1 and onto, then only we can say it is what? Invertible, no? Let x1 and x2 is belongs to R. It is what? Domain, such that f of x1 equals to f of x2. F of x1 equals to f of x2 means 4x1 plus 3 equals to 4x2 plus 3. This get cancelled, x4 and get cancelled. X1 equals to what is remaining? X2 is remaining. So both are equal. Therefore f is 1 1. Okay, clear? So f is 1 1. Now we have to check whether it is onto or not. Now let y belongs to R. Y belongs to R. This is what? Codomain we have to take. This is what? Domain. This is what? Domain. This is what? Codomain. Okay. So y is belongs to R. Then y equals to f of x. So y equals to f of x. So y equals to 4x plus 3. Y minus 3 equals to 4x. So x equals to y minus 3 divided by 4. No? The simplification steps. X equals to y minus 3 divided by 4. X equals to y minus 3 is divided by 4 is belongs to R. Why? For all y is belongs to R. So this is onto or not? Yes, corresponding to every y is belongs to R is a codomain. There exists y minus 3 divided by 4 is belongs to R as a domain, such that this is what onto f of y minus 3 divided by 4 equals to y only we are getting. Therefore f is onto. Therefore f is onto. Then if f is onto, hence what we can say? Hence f is invertible. F is invertible. If f is invertible, we can find the inverse of that. If f is invertible, we can find the inverse. So now let y equals to f of x. Then y equals to 4x plus 3. You know that x equals to what we are getting? Here we got x equals to y minus 3 divided by 4. We got that x equals to y minus 3 divided by 4 in the previous part. Okay. Now therefore it is invertible means f inverse of y equals to y minus 3 divided by 4, or f inverse of x equals to x minus 3 divided by 4. X minus 3 divided by 4. So these are the what? Inverse. Therefore y equals to f of x and x equals to what? F dash of y. So that is a inverse. So now question number 8. Consider f from r plus to 4 comma infinity. It is given that f of x equals to x square plus 4. Show that f is invertible with the inverse f inverse of f is given by f dash of y equals to root of y minus 4. Then where r plus is about non-negative real numbers. Okay. So here first I have to consider f of x equals to x square plus 4. We have to check whether it is a invertible or not. So it means let x1 x2 is belongs to r plus such that, so we have to prove that it is a 1 1 or not. F of x1 equals to f of x2. So it is x square plus 4 means x1 square plus 4 equals to x2 square plus 4. This get cancel. X1 square equals to x2 square. So x1 square equals to x2 square means x1 is equals to plus or minus x2. But here it is what? X1 equals to x2 only. Why? That this belongs to what? R plus. Only the positive integer we have to consider it. Therefore f is 1 1. Therefore f is 1 1. Otherwise this is not a 1 1 function, but it's only we have to consider r plus real number, all non-negative real numbers. No, that's why it is what? X1 and x2 are equal. Therefore f is 1 1 function we can say. Now let y equals to y is belongs to 4 comma infinity. No, y is belongs to 4 comma infinity, and f of x equals to y we have to consider it. Let y equals to f of x. So y equals to f of x means x square plus 4 equals to y. Then x equals to what we are getting? X equals to y minus 4. X square equals to y minus 4. X equals to root of y minus 4. X is greater than or equals to 0. Because so x equals to what? Root of y minus 4. So if x equals to root of y minus 4 means x is equals to root of y minus 4 is belongs to R or not? Yes, belongs to R. Therefore what? F is on to. Therefore f is onto. If this is 1 1 and onto function, therefore we can clearly say it as invertible function. It is what? Invertible. So invertible means therefore f dash is exists. So now we have to find f inverse of f. So let f of x equals to y, you know that. So what is that? X equals to what we are getting? Already we got here x equals to root of y minus 4 we are getting. Then therefore y dash of y equals to root of y minus 4, or f dash of x equals to root of x minus 4. So this is our inverse. Okay, so this problem we have to simplify in this way. So this is one of the very important problem. This problem is asked in the different years, 2015, 2016, 2018 and 2018 both the time, March and June. Supplementary also it may came. So it is for 2 times. This is as for you may think in the coming years also this is one of the important problem. So now move to the question number 9. Question number 9. So question number 9 is this also what is a positive integer, real number, sorry, not positive integer, it is what real numbers. Minus 5 to infinity is given by f of x equals to 9x square plus 6x minus 5. Show that f is invertible with the f inverse of y equals to root of y plus 6 minus 1 divided by 3. Okay, so this is a problem we have to simplify it now. But real is minus 5 to infinity. Minus 5 is also including. Now, f of x equals to what is given? F of x equals to 9x square plus 6x minus 5 is given. Okay, first we have to prove it is a invertible or not. So yes, it is invertible or not, we can follow in the different way also. So this is one more method we can simplify it. How can you simplify it? Let y is belongs to minus 5 to infinity, then y equals to f of x. So x belongs to what? R. Okay, so now y equals to 9x square plus 6x minus 5. So y equals to 9x square 6x plus 1. So we have to simplify it now. So 9x square plus 6x plus 1 minus 6 we can write. Okay, so this is about one of the term completing the square method you have studied in 10th standard. So this can be written as 3x plus 1 whole square minus 6. Okay, so now 3x plus 1 whole square minus 6 means is sent to here say side y plus 6 equals to 3x plus 1 whole square. Now 3x plus 1 equals to root of y plus 6. 3x equals to root of y plus 6 minus 1. X equals to root of y plus 6 minus 1 divided by 3. We got this relation. So you know that this is our simplification. This is one of the important step. Here minus 5 can be written as plus 1 and minus 6. How can we write like this? We have to apply the completing the square method you are studying in the 10th standard. Okay, so now so x equals to what we got? Root of y plus x minus 1 divided by 3 we got. Now let us define. Okay, so one more function we have to take it. Let us define g from 5 to infinity. 5 to infinity is r plus, okay, by g of y equals to root of y plus 6 minus 1 divided by 3. So this one you can consider it as g of y equals to this. Okay, so now g of f of x equals to g of f of x. What is given? F of x is this 9x square plus 6x minus 5. 9x square plus 6x minus 5. This can be written as g of 3x plus 1 whole square minus 6. We know that. So already we written. Now g of x is this, no? Okay. So g of x. Now this is what x. It means x. So I have to substitute in the term. Okay. Now this one I am getting root of 3x plus 1 whole square plus 6. Sorry, this is what minus 6 plus 6. Okay. So this is plus 6 minus 6 and minus 1 divided by 3. Okay, what is this? This is what x, it means y. So full term I have to write 3x plus 1 whole square minus 6 plus 6 and minus 1. So now I can cancel these two terms here. So it will become a 0. Now this root and this one I can cancel now. So what is remaining? 3x plus 1. 3x plus 1 and minus 1 divided by 3. So these get cancelled. 3 and 3 get cancelled. What is remaining? X is remaining. Okay. Now and one more thing we have to prove, that f of g of x. Okay. So now this is what f of g of y. Okay. Here it's what 5. Now f of g of y is equals to f of g of y is root of y plus 6 minus 1 divided by 3. Okay. Now 3 is, now f of x is what? It's what? 9. 9x square means 3x plus 1 whole square. So 3x plus 1 whole square means root of y plus 6 minus 1 divided by 3 whole square plus 1 whole square minus 6. Okay. So this is our 3x plus 1 whole square. So x is what? This one, 3 of y plus 1 whole square. Okay. So now this becomes, what is that now? So here it is for 3 and 3 get cancelled. 3 and 3 get cancelled. Now this becomes plus 1 and minus 1 get cancelled. Okay. So what is remaining? Y plus 6 root of y plus 6 whole square minus 6. So now this get cancelled. Y plus 6 minus 6 equals to what? Y. So now we got that answer as, therefore f of g of y equals to y. So it means therefore g of f equals to IR plus, and f of g equals to what is that? I of 5 to infinity. I of 5 to infinity. So now which is the invertible? Therefore it is invertible or not? So both are reversible, no? Invertible. That this implies f is invertible. F is invertible with f inverse equals to g. F inverse equals to what? G. Therefore f dash of y equals to g of y is equals to what is that? Y plus 6 minus 1 divided by 3. This is our solution. Now next question, number 10. So how can I simplify? See now, let f from x to y be an invertible function. Show that f has unique inverse. F has unique inverse. So how to prove this? So unique inverse means so only one inverse. It is what? It's equal. We have to show that. Now the given condition is what? F from x to y is an invertible function. So f from x to y is invertible, is given. Is what? Invertible. So invertible means what? We cannot prove 1 1 and onto this. Already it's a given 1 1 and onto. Okay. So suppose we have to consider now. Suppose g1 and g2 you consider be the two functions. Be the what? Two functions. Okay. Of f. So you have to consider g1 and g2 be the two functions. Then for all what y belongs to y. Okay, for all y belongs to y. So now f of g1 of y equals to what? Iy or not? So iy of y. Okay, so equals to what? F of g2 of y. Yes or no? So both are the same function. It's invertible. So f of g1 of y f of g1 of y equals to iy of y, and equals to what? F of g2 of y. Both are same, no? Now this implies what we can say? F of g1 of y is equals to f of g2 of y. So both are equal. So now f g1 of y equals to f g2 of y. G2 of y. So now g1 of y equals to g2 of y. G2 of y. Because f is 1 1. Because what? F is 1 1. So this implies what? G1 equals to G2. G1 equals to G2. Therefore f has a unique unique inverse. Therefore f has unique inverse. Okay, so this way we have to simplify it. So now the next one is 11th one. Consider f from 1, 2, 3 to a, b, c. So given by f of 1 equals to a, f of 2 equals to b, f of 3 equals to c. You can see that question in the textbook. Find f inverse. F inverse we have to find. And also show that f inverse of inverse equals to what? F. So you know that in the sets already you studied a complement of complement is a only, you know that, right? So the given thing is what? F from R to 1, 2, 3 to what is that? A, B and C. Okay, so now f of 1 equals to a is given, f of 2 equals to b is given, next f of 3 equals to c is given. Okay, this is a very simple problem. You can simplify it. So f of 1 equals to a, f of 2 equals to b and f of 3 equals to c. Here this is what this implies what? F is 1 1 and onto function. Yes, clearly we can say this is what 1 1 and onto. It means x1 and x2 are equal and the values are different and all things are there. Here is a function. So f is 1 1 and onto. So when f is 1 1 and onto, you know that f1 equals to a, f2 equals to b and f3 equals to c. These both are different. So one is f of 1 equals to a and f of 2 equals to b. So it means x1 equals to x2. So it is different things we are getting. Okay, so now therefore it is what? 1 1 and onto function we can say. So if it is 1 1 and onto, clearly what we can say, this is what? Invertible. So invertible means f dash f inverse is exists. So we can find the f inverse. How to find the f inverse? Therefore f inverse is equal to y comma x when x comma y is belongs to f. Okay, so f inverse is y comma x when x comma y is belongs to what? F. So this implies f dash is equal to what now? What? So here it's a given 1 equals to a means this is what? A comma 1. Okay, f inverse. 2 and b means b comma 2. It is what? Inverse. Now it is what? C comma 3. So this is what? F inverse. Okay. So now next let f inverse equals to g, then g equals to what is that now? Oh, a comma 1, b comma 2 and c comma 3. No, so these both are equal. So now g of a equals to what? 1. G of b equals to what? 2. And g of c equals to what? 3. Okay. So now we can say that this is what? G is 1 1 and onto. Okay. So then g of a is 1 1 and onto means g inverse is exists. So g inverse is exists means g dash is what? 1 comma a, 2 comma b and 3 comma c. So this means equals to what? F or not. So this implies f inverse of inverse equals to what? F. So this is our proof. These all are simple problems. Next 12th one. F from x to y be an invertible function. Show that inverse of f inverse is f. That is f inverse of inverse is what? F. So it means here it is what? Since f is invertible. F is invertible. So f is invertible means f of x equals to y and f dash of y equals to what? X. For all x belongs to x and y belongs to y. You know this. This is what invertible means, f of x equals to y and f dash of y equals to x. Okay. So now next, f from x to y and f dash is y to x. Okay, so f is x to y means f dash is y to x. You know this one. Next, this implies f of f inverse of y equals to what? Iy. Iy, then into what? Y. And f inverse of f of x equals to what? Ix into x. Okay, so now let y1, y2 is belongs to y such that f of f inverse of y1 is equals to f inverse of y2. F inverse of y1 and f inverse of y2 means f of f inverse of y1 is equals to f of f inverse of y2. Then this becomes what? F of, so f of f inverse of y1, no? Here it is f of f inverse of y1 equals to f of f inverse of y2 is written. So now this is what? F of f inverse of y1 equals to f of f inverse of y2 we can write. Okay, now here f naught y inverse, sorry, f of y inverse of y can be written as iy into y, right? So here I am writing iy of y1 equals to iy of y2. So iy is a common. So what I can write? y1 equals to y2 I can write. y1 equals to y2. y2. So this is y1 equals to y2 means therefore f inverse is 1 1 or not. Yes, it is what? 1 1. y1 equals to y2. So now we have to check whether it is onto or not. So here x is belongs to x, no? X is belongs to x. There exists y equals to f of x. There exists y equals to f of x. Equal, it is belongs to what? Y, no? Such that f inverse of y equals to x. It means whatever the values are there, its x belongs to x and y equals to f of x is belongs to y. That is implies it is what? Y f inverse of y equals to x. It is what? Same thing. Therefore f inverse is also a onto. Is onto. Okay, so here is both this is a 1 1 and onto. Therefore what we can write it here, it is f inverse is invertible. F inverse is invertible, we can consider it. So when once it is what? Inversible, now we can find out the we can prove that what is that? F inverse of inverse equals to what? F. So let g equals to what we can write? Let g equals to f inverse of inverse. Then now g of f inverse equals to iy and f inverse of g. F inverse of g equals to what? Ix, no? Is what? Ix. G of f inverse is iy and f inverse of g equals to what? Ix, we can consider it. Now for all, so for all x belongs to x, x belongs to x and ix of x equals to what? X. Ix of x equals to what? X. You know that. Now f inverse of g of x equals to x. F inverse of g of x equals to x. Why it is x? Because f inverse of g equals to what? Ix, no? It is what? Ix. This is what reason we can give. F inverse of g of x equals to x, we can give the reason. So now f of f inverse of x equals to what? Here it is g. Yes, f of f inverse of g of x equals to what now? F of x we can write. F of f inverse of g of x equals to what we can write? F of x. Why? This full function is what? X. So now f of x is what? F of x. Now this implies f of f dash of g of x equals to what? F of x. This implies g of x equals to f of x. Why? F of f dash of x is iy. f of f dash of equals to what? Iy. So this is g of x equals to f of x. So now this implies what? G equals to f. The function g is equals to f. This implies f inverse of inverse equals to f. Why? G is equals to, already we considered, f inverse of inverse. Here it is what considered, it is what g. No, I'm sorry, here g equals to f inverse of inverse we consider. So this is a proof of that 12th problem. So I hope that all of you understood this one. Now next 13th question. How can we simplify this 13th one? Let us see now. If function f from R to R be that f of x equals to 3 minus x cubed to the power of 1 by 3, then find f of x is, we have to find its dash. So this is what the multiple choice question is given. Okay, so now how can you take this? F of x equals to what is given? 3 minus x cubed to the power of 1 by 3. Now f of x equals to f of x. So now f of x is 3 minus x cubed to the power of 1 by 3. Now f of this is what? 3 minus x. X is 3 minus x cubed to the power of 1 by 3 to the power of 1 by 3. To the power of 1 by 3. So x cubed to the power of here it's 3 is also there, 3 to the power of what? 1 by 3. This is 3 x cubed to the power of 3 whole to the power of 3. Okay, so now which are that get cancelled? This and this get cancelled. Then it's remaining, it is what? 3 minus 3 of so you can cancel this 3. Okay, 3 minus 3 plus x cube to the power of 1 by 3. So you can cancel these two, not this. These two you can cancel it. So 3 minus 3, this get cancelled. Now this also get cancelled, equals to what? It is at x. So once it is what? X, so what is the value? So A option is x to the power of 1 by 3, and B is x cube, and C is x, and D is 3 minus x cube. So the answer is x. Now next question, it is what? 14. If f from R minus of minus is f from R minus of minus 4 by 3 tends to R is defined by the function f of x equals to 4x divided by 3x plus 4. The inverse of f is map G. It's what? Range f from f to R minus 4 by 3. So 4 options are there. Which option is the correct option? We have to check now. So which is the correct option? We can check now. We have to find the g of y now. So let y equals to f of x and f inverse of y equals to what? X. You know that you can consider that relation. Now after taking that thing, we have to prove now. Y equals to what? This one. Now y equals to 4x divided by 3x 4x divided by 3x plus 4. So y equals to this. Then cross multiply it, 3xy plus 4y equals to 4x. Okay, so here we have to keep it x outside. Means 3x 4y equals to 4x minus 3xy. 4x minus 3xy. So what we can take it what outside down here? X we can take it outside. 4 minus 3y. So 4y divided by 4 minus 3y equals to what? X. So now this is what? X. X equals to 4y divided by 4 minus 3y. 4y divided by 4 minus 3y. So which option is the correct option? B option is the correct option. Therefore this implies what now? This implies f inverse of y equals to 4y divided by 4 minus 3y. Clear? So this implies g of y equals to 4y divided by 4 minus 3y we have to take it. So now g of y equals to 4y divided by 4 minus 3y. So now in this exercise number 1.3, so all the problems are over. So only one problem is remaining. I said I will explain at the end. Why means here it is what sum and product is there. So before that we can understand all these problems. So now this is what very easily you can understand it. Okay. So now let f, g and h be the functions from R to R. Show that f plus g of h equals to f of h plus g of h, and this is what into we have to prove like this one now. Okay. So how to simplify that problem? Let us see now. Here the condition is x, I am considering x. So second one, x is belongs to R. So for all the x belongs to R I am considering. So first problem, it is f plus g of h equals to f of h plus g of h we have to take. So now this one I am taking now, f plus g of h of x equals to, how can I write, f plus g of h of x, no? So h of x. So this becomes f plus g of h of x. So now f of h of x, so f of h of x plus g of h of x. G of h of x we can write. F of h of x plus g of h of x you can write. Otherwise directly you can write what? F of h of x plus g of h of x we can write. So f of h of x plus g of h of x. So this one how can you write now? F of h of x plus g of h of x we can write. So now x is a common for all the things. So what we can write? F plus g of h equals to f of h plus g of h we can write. So this is our first part is over. So now in the second one, second one is f dot h g of h equals to f of h in d of h. So same way we have to consider it. So this one I am taking f of g of h of x we have to consider it. Now this is what f dot g, we have to consider what h of x we can write. So this is what h of x. Now f dot h of x, okay, so sorry, f of h dot g of h of x we can write. So now this becomes f dot h, this becomes f of h of x dot g of h of x we can write like this, no? So now x is a common, so what is the things we can write? F dot f of h equals to f of h dot g of h we can write. Clear? So this is a very simple one, so we can write like this.